the center, that will be the neutron and proton, and electrons are present around the shell, right? And they are the different shells are there, and these different shells are having fixed number of fixed number of electron that they can accommodate. So this model was given by the Bose, and he said that like earlier so many models were there that was related to the structure of an atom, but the Bohr has given the structure of an atom which was stable in nature, and we said that like here the number of electron in the shell is limited, right? So and they are having a fixed amount of energy, then only the electron can accommodate in these shells. And if the energy level is higher, then they will go to the next level, and so depending upon the energy level the number of electrons are fixed. Like if I will say that these are the K, L, M and N, these are the shell, so the maximum number of electron is 2, 8, 18 and 32, right? Now if we will go for the subshell, so what are the subshells they are having? Uh, yeah, so they will have S, P, D and F, right? This S will have 2 electrons. P can accommodate how many electrons? 6. What about D?
10.
And what about F?
14.
14 electrons are there. Yeah. So here this is how like the electrons are arranged in the different shells or different subshells. So if I'm saying that the L, K will have definitely one subshell, that is S. Now if we will go for L shell, so it can accommodate 2 subshells, right? Like if I will take 2s2, so subshell S is full. Now rest of the 6 electron, they will go to the P subshell, right? So this is how we are arranging the electrons. Yeah. Then if I will ask you M is having 18 electrons, so M can accommodate maximum 18 electron. So is that like they all will go to SP and D, like like if I am writing as a 3s2, then 3p6, then 3d10. So this is how like 18 electrons can be arranged in third subshell.
Yeah.
But there is a one twist. So let me.
4s2 comes before 3d10.
Yes, 4s will come before the 3d10 comes. So I want to add one more pages. Yeah. So if I will draw the picture, so it will go like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. Like this, the electrons will be arranged in a different subshells. Now, do you remember like if we are arranging the electron in a periodic table, so that periodic table is having in our left hand side S block element is there, then D block element, then P block elements are there, and all S block elements we are considering them as a metal, right? Alkali and alkaline earth metal. So here first of all we will arrange first subshell, then second subshell, then P, and then third one. After fulfilling the 3s2, we will go to 4p6 and then we will go for 4s2, right? So if I have to write down the electronic configuration, so I will write like this: 2p6, then 3s2, right? And then I will write 3p6, then I will go for 4s2. So how many electrons are there? Can you count?
Right, so I have
10.
20,
Yeah.
20,
So is it 20?
yeah,
Yeah. So calcium, which is having mass number 40 and atomic number 20, so its electronic configuration is 4s2. The outermost shell will have 2 electrons. So whatever the chemical reaction calcium is showing, this is due to the presence of these outermost electron, right? So the question arises like why the electron does not go to d subshell, but instead of that it comes for 4s2.
because it's a lower energy level.
Than 3D time.
Yeah, so as we said, like electrons are arranged into subshell according to their energy level. So here now again one more twist is there. Like if we are having, suppose I'm not going to write all this. So if we are having, suppose I'm writing from here 3s2, 3p6, then 4s2, then already this will go to 3d. 3D4, then after 3D it has to go to yeah, after if 3D4 is there, then what changes will happen? Yeah, is
It
there
will go
any
to
like am I
4 people.
is this like electronic configuration is right?
No, because it should be fine at once.
So what will be the next or the correct one?
Oh, 4 people.
4p?
Yeah,
No dear, like here what will happen? This d subshell is having 4 electron. So what we consider, like if d subshell is having 5 electron, so it had reached, because if we will draw the boxes, right? So 1, 2, 3, 4. 1, 2, 3, 4 and 5. So first we will arrange the electron in an upright direction, right? So here if 4 electrons are there, so if it will gain 1 electron, so it will become stable. So here what changes we are making? We are now changing the electronic configuration. Here 4s will donate 1 electron to 3d, and here 3d will turn as a 5. So this will become more stable. Okay,
okay.
now whatever the next electron is there, so that will go to the 4s2, and here after 4s2 then again the 3d will increase. Now the next twist will be again where we are having 3p6, and the next electron again we will arrange in a 4s1, and here it will be 3d. If it is, if like suppose here 2 and here 3d will reach to 9, so what will happen, like this 9 is again unstable by only 1 electron, so this 4s will give 1 electron. So here again the electronic configuration will change, and this electronic configuration will turn as a 3p6, 4s1 and 3d10. This is how the atom is attaining stability. So these all arrangement of electron are based upon their energy levels, right?
Yeah,
So am I going correct?
yeah,
So these are the two twists that you can see in D subshell. Then rest of the pattern will be same, like first you will fill 2, 8, 8 and 2, and then you will come back to 8, then you will go for 2, 8 up to 18, and this will 2. So this is how like we are writing the electronic configuration of a element.